After watching the tutorial on limits, now we're going to investigate how we find the limit of a function numerically and graphically. So if we take a look at our first function, x squared minus 1 over x minus 1, we want to try to find the limit of that function as x approaches 1. In the limit tutorial, for many of the functions, you were able to simply substitute 1 in for x and find the value of the limit. Unfortunately, for this function, if we try to substitute if we try to substitute 1 in for x, we run into a problem. We get 1 squared minus 1 over 1 minus 1, which equals 0 over 0, and that's undefined. So we cannot just simply plug 1 into our function and find the limit. What we can do instead is we can plug in numbers that are very close to 1 and see what value the function is tending towards. So take a moment and pause the video and plug in the following numbers in the table into the function, and we'll see what values we get for y, or for f of x, and then we'll try to guess what the limit of the function is as x approaches 1. After plugging in the values into your calculator, hopefully you got the following results for your table: 1.9, 1.99, 1.999, and then 2.001, 2.01, and 2.1. So it looks like that the value 2 was the value that got skipped at 1. So it looks like that the function is tending towards the y value of 2 as x approaches 1. And that is the limit of our function as x approaches 1. So this numerical way will always work to help you find the limit of a function if we cannot use substitution. We simply just plug in numbers that are very close to that number on either side of it, some that are smaller, some that are bigger. Now we're going to move on to finding the limit of a function at a certain x value just by looking at the graph. So you can stay on this page, and I am going to move to the next page, which is the graph of the function. First, we want to find the limit as x approaches negative 6 of our function f of x. Now this is our function f of x. It's represented as a graph. So what we want to do first is go to the x value of negative 6, which is right here, and we notice that there is actually a point at that x value, and the coordinate is negative 6, 0. So the limit as x approaches negative 6 of f of x equals 0. That is the y value at the point negative 6 for x. Let's take a look at number 2. The limit as x approaches negative 5 of f of x. Again, at the x value negative 5, we do have a coordinate, and it's negative 5, 2. So the limit as x approaches negative 5 of f of x equals 2. Since there is a coordinate there. Try number 3 on your own. The limit as x approaches negative 3 of f of x. If you came up with the answer 3, you are correct. There is a point at negative 3, 0. There's actually a hole at negative 3, 0. So this could get a little bit confusing, but if you remember from the tutorial, if the graph is approaching a hole from both the negative and the positive side, then the limit is where the hole is, and the hole is at the y value of 3. So the limit as x approaches negative 3 of f of x is 3. Now we're going to find the limit as x approaches negative 2 from the negative side of the graph. The little negative that's in the upper corner of next to 2 means that we approach it from the negative side of the graph. So, as we can see, there is an asymptote at the x value -2. So I'm going to follow along my graph, but approaching it from the negative x values. So as I'm following the graph along, it looks like that we run into the asymptote, but the graph keeps going up towards infinity as it gets closer and closer to that asymptote. So the limit as x approaches -2 from the negative side of f of x equals infinity. Now let's see what the limit of the function is as x approaches -2 from the positive side of the graph. So again, I am going to follow along my graph towards the asymptote -2, but this time I'm coming in from the positive side. And again, my graph is going up towards infinity. Now, number 6 says, what is the limit as x approaches -2 in general? It's not asking us from the positive or the negative side. Since on both sides of the asymptote, from on the negative side and on the positive side, the graph is tending towards infinity, the limit at -2, even though there's an asymptote there, is infinity. Part of the definition of a limit is that it needs to approach it from both the negative and positive side and be the same number. So the limit as x approaches -2 of f of x in general is at positive infinity. Okay, so now we'll move on to our next set of problems, number 7. The limit as x approaches -1. So at -1, we have a coordinate, and it's -1, 3. So the limit at -1 would just be 3. The same thing at 0. At x equals 0, we have a point at 1. So the limit as x approaches 0 would be 1. Now we want to find the limit as x approaches 1 from the negative side. At the x value 1, we do have a coordinate at 1. So if we approach it from the negative side, the y value would be 1. So the limit as x approaches 1 is 1. Let's do the limit as x approaches 2 from the positive side. So at the x value 2, which is right here, if we approach it from the positive side, we also have a y value at 1. So the limit as x approaches 2 from the positive side is 1. Now let's find the limit as x approaches 5 from the negative side. So as we are approaching 5, we notice that at the x value 5, we have a hole at 2, and then we have a coordinate at 4. Well, if we want to approach 5 from the negative side, we need to follow the graph in, I'm sorry, that's the positive side. We need to follow the graph in from the negative side, and as we come in from the negative side, our graph is definitely approaching that hole, which has a y value of 2. So our limit would be 2. Now if we approach 5 from the positive side, now we're coming in this way, and our graph is still tending towards the y value of 2. So that would be the limit. Now it asks us, what is the limit as x approaches 5 in general? That is question number 13. Because we approached 5 from the negative side and got the answer 2, and we approached it from the positive side and got the answer 2, the limit is in fact 2. So we don't want to have this extra point up here throw us off. The limit will always be at the hole if we are approaching it from the negative side and the positive side, and we get the same answer on both sides. Now let's find the limit as x approaches 6 from the negative side. At x equals 6, we notice that we have a hole. Oh, my pen just got really fat all of a sudden. Fix that. There we go. We have a hole, and we have this point up here. So if we want to approach 6 from the negative side, we need to be coming from this direction of the graph towards, oh, I'm sorry, that's the positive. I'm sorry. We want to be coming from the negative direction of the graph, which is this, the negative x values. So we're coming in from the negative x values, and we're approaching x equals 6, and we have the y value of 1. So the limit as x approaches 6 from the negative side of the graph would be 1. Now we want to find the limit as x approaches 6 from the positive side of the graph. So as we approach it from the positive side, we're coming in from the positive x values, and it looks like we end up at the y value of 0 at that hole. So as you can see, we got two different values from the limits. If we came in from the negative side, we got the limit of 1, and if we come in from the positive side, we get a limit of 0. Therefore, the limit as x goes to 6 in general is does not exist. DNE. Because these two y values are different, the limit does not exist at that particular x value. Let's take a look at number 17. The limit as x approaches 7 from the negative side. I'm going to have to, there we go, it's erasing. Okay. So, as we approach 7 from the negative side of the graph, first we notice that we have an asymptote at 7. So if we're coming in from the negative side, we're coming in this way, and the graph is tending towards negative infinity on that side of the asymptote. So the limit as x approaches 7 from the negative side of f of x is negative infinity. Now we want to find the limit as x approaches 7 from the positive side of the graph. So now we're coming in this way from the positive side towards the asymptote, and our graph is going up to positive infinity. So that would be the limit there. Again, because we have two different values at this asymptote, we have a negative infinity and a positive infinity, the limit as x goes to 7 in general of our function is does not exist. There is two different values, so we get a DNE. Before, when we were looking at the asymptote -2, it ended up that there was a limit at that asymptote because both sides of the function were going towards infinity. So kind of a general rule of thumb is if you look at the asymptote and both arrows are pointing the same direction, you will have a limit either at infinity or negative infinity if it's pointing down. If the arrows are going in different directions, the limit will not exist, just like it did at x equals 7. All right, for number 20, we want to find the limit as x approaches 8. So as we can see, at the point 8, or at the x value 8, we have a point at 0. So the limit as x approaches 8 of f of x will just equal 0, since there is a coordinate there.